Hello. Today we're going to be going over arithmetic sequences. So, the goal for today's class is by the end of this, you should be able to determine the value of any given number in an arithmetic sequence. So, first, what is an arithmetic sequence? So, an arithmetic sequence is a list of numbers with the same difference between adjacent numbers. Let's give an example. So here we have an arithmetic sequence, 20, 23, 26, 29, etc. And the difference between the adjacent numbers, so adjacent means numbers next to each other. So the difference between this one and this one, or this one and this one, or this one and this one, the difference between those two numbers is always the same. Here, difference means subtraction. So 23 minus 20 is 3. 26 minus 23. So the difference between each number and the one after it is always the same in an arithmetic sequence. One thing I want to talk about real quick is this little dot, dot, dot here. For those of you guys who don't know what that means that the pattern continues. So this means that the pattern continues. Pause the video here, take whatever notes you want, hit play when you're ready. Okay, so in the previous sheet of paper, this was the example I had given. 20, 23, 26, 29, dot, dot, dot. Okay. So we're going to talk about this being the first number in the sequence, the 20, and then 23 is the second number, 26 is the third number, fourth number is 29, etc. So what if you were asked what is the fifth number? Well, that's easy enough. The fifth number over here, you can just continue the pattern, plus 3, plus 3, plus 3. So the fifth number here is 32. Easy enough. Okay. If you're asked, what is the 10th number? A little bit more work, but easy enough still. 6, 7, 8, 9, 10. So 32, 35, 38, 41, 44, 47. Each time I just added 3 more. Okay. But see, that took a little bit more work. And the further out here you go, the more work it takes to do it this way. And the more work it takes to do it, as you go this way, the more likely you are to make a mistake. So if you're asked something like, what is the 100th number in this arithmetic series. Well, in your head, going plus 3, plus 3, plus 3, plus 3, and counting all the way to 100, there's 95 steps you have to do, so you're likely to get uh, do a mistake somewhere in there if you're doing 95 different steps. So there has to be a better way to do it than just counting all the way to 100. So one way we could do this is, let's say these numbers up here, we're going to call that n. And we'll call these numbers here a of n. This is sort of like your x and your y, okay? And this 20, this is my a of 1, or saying your first number, what's the a going to be? For your second number, what's the a going to be? So a of 2 is 23. For your third number, what is the a? This little symbol right here means the third number, what is the a? It's 26, etc. Okay, so that's just some notation. Now, instead of writing it like this, I'm going to put this into a table, just because in previous math classes, I know you've seen things like this in tables before, so I'm going to make it look familiar to you. Okay, so your first number was 20, second number is 23, third number is 26, fourth number was 29. And I called this one over here n, and I called this a of n. Once again, this is like an x and a y. So if I were to put this onto a graph, here's 1, x equals 1, x equals 2, x equals 3, x equals 4. But I'm calling these n's. And over here, let's have this be where 20 is, 23, 26, 29. Okay. So when n is equal to 1, my a of n was 20, n equals 2, your a of n was 23, etc. Okay. And if I were going to connect these dots to form a line, there you go. So if you're looking at this or at the graph, you can tell this is a linear pattern. Linear means it forms a line. So in previous years, you guys have probably already seen the equation for a linear, the equation for a line, which is y equals mx plus b. So this is m times x plus b. Sure. in this particular, so this is a general equation, and when we're using this for our particular example here, first thing is that we're not really using y's and x's in this particular example. Like I said, the y is like your a of n, or your a of n is like a y, your n is like an x. So let's substitute that in. Okay, so y of n was changed to a of n, x was changed to n for our particular example. And how do you find this m? This m is known as your slope. If we're looking at our graph, the way you find slope is how much does the y change by divided by how much does the x change by. If you're looking for the equation you probably saw before, you saw something like this: y2 minus y1, x2 minus x1. So looking at our particular graph here, you can choose any 2 points. Let's say, for example, I choose this one and this one. And our top of our fraction is how much does the y change by. Okay, let's say I start here and I go to this dot. Well, my y is my up and down, and it goes up by positive 3. Bottom of my fraction is how much does my x change by? Well, my x going from here to here, I go to the right, positive 1. Okay, so that's what my slope is. It is positive 3 divided by positive 1, which of course is 3. If I was looking at my table over here, it's the same idea. How much does, you pick any 2 of these points, and you're like, how much does my y change by? Positive 3. Divided by how much does my x change by? Positive 1. And once again, this side is like your y, this side is like your x. Okay, so once again, positive 3 divided by positive 1. The slope here is 3. All right, this b here, that is called your y-intercept. Okay, and your y-intercept is just where does your line touch your y-axis. In this case, obviously it touches it right here. That's where your b is. And at this very spot, your y is equal to how much? And we know anything on this line, your x is 0, and so we're just trying to find what is that y. And here, that is 17. If we were doing that on our table, once again, your y-intercept is when your x equals 0. And we need to find that number. Well, I know that if I'm going in this direction, it's plus 3, plus 3, plus 3, going down. So if I'm coming up, starting at 29, going this way, it's minus 3, minus 3, minus 3. So to go to this one, it's going to be minus 3 again. Sorry. Minus 3 to get to 17. And that is a positive 17. So my y-intercept is positive 17. So this equation right here tells you for any particular n, what is the a of n equal to. Pause it for a second and write down whatever notes you want. Continue when you're ready. So let's now answer our question up here. What is the 100th number? Okay, so if you have this equation right here and you're trying to find out what is the 100th number, this 100 right here that is your n. So n here is equal to 100. And this is your n equals 1, your first number, n equals 2, second number, n equals 3, third number. So your 100th number is your n is equal to 100. Okay, so we have our equation that tells you for whatever n, how much is the a of n going to be? How much will that number be? So we're right now substituting n equals 100 into our equation. So anywhere you see an n, you change it to 100. So I change that n into 100. You have 3 times n, so 3 times 100. Notice as I'm substituting the n into the equation, every time I substitute it into my equation, I put it in parentheses. That's always a good habit. So when n equals 100, let's find out what a of 100 is. So 3 times 100 is 300 plus 17 equals 317. So my 100th number in that sequence is 317. Pause here, take whatever notes you want, and I'll see you wonderful people in class.